In this video, we're going to look at Linux stack buffer overflows. So I have a very simple program here. I start out, I include string.h. I have a function called function, and it takes a single parameter that is a string, and it also declares a local buffer that is 10 bytes long. So that gives me 9 bytes plus a terminating null. And then I foolishly call strcpy, and I copy whatever was passed in to local. I have a standard main method, and it calls function with a user supplied parameter off of the command line, which is always a bad idea. And then I return. So let me go ahead and compile this function. Go to my terminal here. So my command is going to be gcc for the compiler -ggdb. Now what this does is it creates debugging information, and it also creates additional debugging information for GDB. So if I gave it just a -g, it would give me debug information. Now, if you're reversing someone else's code, they might not have done this for you, but this will make it easier when we're looking at some examples. As we said before, I have to give it the no stack protector option. And the reason I have to do that is Linux is too smart to allow me to smash the stack. I then give it my C file, linux-stack.c, and my output will be linux stack-nsp for no stack protector. So I can go ahead and run that, and it runs. Now I'm going to do the same thing, but this time I'm going to edit this slightly, and I'm going to take away my stack protector. I'm going to keep my debugging information, and I will make my output just Linux stack. So now if I run this program, I'll run this one first, Linux stack, and I give it an acceptable input. So I'll give it 8 bytes, and it returns normally. What if I give it 16 bytes? I'm still good because I haven't overflowed anything critical just yet. And I'm still good. Just a little bit more. And there we go. It's going to tell me, hey, you tried to smash the stack. Notice what happened here. It told me stack smashing detected, terminated. And it says my program was aborted. So why am I making a big deal about this? If I don't terminate the program, the malicious user could take control of the program and redirect the program flow. They could inject some shell code, or they could have me running something I don't want to run. So it is much safer to just kill the program. And that's exactly what's being done here. So it's getting a signal abort, and the program is aborting. So I don't have much of a chance as an attacker of redirecting to my shell code or something else. Now, what if I take the same program and I run the version with no stack protector? I will give it some input, and I didn't have to give it much in order to get a seg fault. And you might wonder, why is that? Why didn't I have to give it very much input for it to fail? So here's 8 bytes, and this should work. Here's 9 bytes. This should also work. And if I go to 12, I'm still good. 14 is still good. 15 is still good. And 16 must be the edge where it stops working. Although apparently it worked this time, which is a bit peculiar. Perhaps I missed a character. There we go. And it's failed once again. If I have the stack protector, I'm not going to get the behavior that I want. If I have a stack protector in place, which is the default, it will not allow me to get a seg fault, or in other words, it won't allow me to redirect the program to a different location. We're going to take a little break, and when we come back, we'll look into this a little bit more.